As the boundaries of science expand and globalism makes human experience more interrelated than ever before, it becomes increasingly difficult to develop a firm grasp of just one discipline, let alone many. A consequence of this is a widening gap between the humanities and the sciences, and a subsequent realization that we need a more comprehensive and interdisciplinary approach to learning. Today's guest, Reverend Dr. John Polkinghorne, is a man of many accomplishments. He's a professor of physics with an extensive research background in elementary particles, a member of the Royal Society in England, a knighted sir, and an ordained priest. Welcome to Matter and Beyond. I'm your host, Laura Wells. In this episode, we will look at what the study of elementary particles in fundamental science inspires in a soul enlightened by belief in God. We hope that you will catch a glimpse of the fruits of extensive study encompassing both science and religion.
As a young boy, I was very good at mathematics, and it's a very exciting sort of subject. So when I went to Cambridge University as a student, I went there to study mathematics. And during my undergraduate years, I got very interested in the fact that you can use mathematics to understand the physical world.
Dr. Polkinghorne's interest in the use of mathematics to understand the world led him to complete a PhD in particle physics while studying under Paul Dirac, a well-known quantum physicist.
So that when I came to do a PhD, I did it in theoretical physics, working in fact under a very distinguished Pakistani theoretical physicist, Abdus Salam, who later on won a Nobel Prize. And that led to a 25-year career working in theoretical elementary particle physics. That's to say, using mathematics to try and understand the behavior of the smallest bits of matter. And it was a very enjoyable and interesting life to live.
Polkinghorne entered the field at an exciting time of rapid developments in science's understanding of particle physics.
Elementary particle physics is obviously a fairly fundamental branch of physics. It's studying the constituents out of which the physical world is made. It was also a subject, when I entered it, which was a very exciting stage. New experimental material was coming along. The theorists were puzzled by what they were being discovered at first. And during the 25 years I spent on the subject, we moved from thinking of protons and neutrons as being the constituents of matter to recognizing that they themselves were made up of yet smaller constituents, which are called the quarks and the gluons that make them stick together.
The developments in physics that Dr. Polkinghorne refers to also led to a desire in people to devise a more complete and all-encompassing theory. However, people still differ on what that would mean.
And even if you've got a complete theory of elementary particle physics, it wouldn't be a theory of everything, really, even within physics. Understanding, for example, how fluids behave or understanding superconductivity would be a different area of physics. So one shouldn't get too grandiose or bombastic about elementary particle physics. It's very, very interesting and it's very important, but it isn't the whole story.
While particle physics explores the smallest units of nature, the aspects of physics which are most relevant to daily life lie on the intermediate scale between the very large and the very small. Paradoxically, what lies between small and large is also the most complex.
It is interesting that the physics of the small scale, which is the quantum physics that I worked in, and the physics of the large scale, which is relativity theory and cosmology, they are fundamental physics. Somewhere in between, at the sort of middle level between the two, is human life and biological life. And that's too complicated, really, to understand in very great detail. But the very large and the very small have a simpler structure.
Polkinghorne describes the Big Bang theory as the meeting place of theories explaining the smallest units of existence and theories that explain how the universe operates on the largest scale.
And interestingly enough, of course, if you're interested in something like the Big Bang, the origination of the universe, then you need to put the two together, because You're talking about the universe, so you need relativity theory, but the universe is very small when it begins, and so you need quantum theory. So the two actually meet, so to speak, in the neighborhood of the Big Bang. And that's really fundamental physics.
Developments in the theory of relativity, quantum theory, and the establishment of standard theory inspired Dr. Polkinghorne to look for a change. He felt he had done his part for physics, and it was time to leave the ever-changing mathematical model to new scientists.
My transition from being a professor to a priest was partly conditioned by I reached that stage in my life where I felt I'd done my bit for physics. Also, the subject was changing. The quant theory had really got established, the dust had settled on it, so to speak, what we call the standard model now had got established. Physics was changing its character, string theory was coming along, it was all becoming much more speculative, with a different sort of mathematics, which I didn't know so well. So it was quite a good time for a change.
The success of 20th century science rests on its enthusiastic and relentless study of existence. Dr. Polkinghorne emphasizes the importance of experiencing the reality of a phenomenon as a whole. The process of carefully examining small parts can reveal important knowledge, but this process can overlook the depth of meaning and impact derived from simply experiencing the whole.
Well, science's technique on the whole has been divide and rule, to split things up into their bits and pieces, because it's easier to understand bits and pieces than it is to understand things in their complex totality. And of course my own particular science of elementary particle physics carries that to the nth degree.
Reverend Dr. Polkinghorne's experience in particle physics taught him the strengths and weaknesses of searching for knowledge in the most pared down and small-scale contexts.